Okay, so what do we have here? We have um, CCV, and it is a bit of a long-winded question, but it actually is not a bad question at all. You just have to kind of just take your time, make sure you have a fresh head, and just get into it slowly. So it says that this business CCV manufactures four products. MDCL, I wonder where they got those letters from. Each of the products is manufactured in batches of 50. So I think it's just making sure you break it down slowly. So they make these products in batches of 50. So they've just recently started using a just-in-time manufacturing process, and they have little or no inventory. So we don't have to worry about opening or closing inventory. So it says that the batch sizes of 50 units can't be changed in the short term. So they make these things in batches of 50. So that's what we're always going to be doing. So in terms of setting up and things like that, it's always going to be 50 units per batch. So it says despite being manufactured in batches of 50, they are sold as single units. Okay, very competitive market. So it's very little you can do with your pricing. So you really have to be looking at your costs, right? That's kind of the point here, because you have a ceiling with pricing, you really have to focus on getting your costs down, in effect, to get the profitability or the contribution you're looking for. So it says you're currently reviewing the profit made for each product, and this is what you're seeing. So you're selling these number of units. These are your labor hours, your machine hours, and this is what you're seeing. You're seeing revenue here, materials, labor, and these overheads giving you profit here, right? And that's what you're looking at. So hopefully you've read this. And this is, to be honest, there's very little you can do about this. These are just set activity costs, right? They're variable. Make more units, you have more labor hours. Same thing for machine and that sort of thing. So, and you can't do anything about your pricing either. So the question here is, how do we think about reducing our costs? The other thing here is that D&C look like unprofitable products because overall they're giving you a net loss of 75,000 respectively and 50,000 respectively. So naturally you would want to then eliminate both these products technically because they're making net losses. But again, what we have is, let's look at what they're telling us. They're concerned that two of the products are losing money and have asked for an analysis of the overheads. Now, remember, the problem with overheads is that we spread overheads based on a certain formula, and sometimes that might not be the best way of doing things, which is why we have the evolution of going from traditional absorption costing, right, to um, to activity-based costing, and that gives us a slightly more a better refined analysis of overheads. So um, And so what do we have here? So it tells us the sales are completely independent of each other. And it currently says that currently an overhead recovery rate of £3 per machine hour has been used to share out. So currently they're spreading this overhead cost, the total overhead cost based on machine hours. So they've got a budget and they're doing £3 for every for all the relevant machine hours. So 3 times 75,000 will give you this. 3 times 75,000 will give you this. So you're basically multiplying 3 times. You can see 3 times 2 is 6, so 600,000. So that's what they're currently doing. But we think we can do it better. So because this overhead, this, to a certain extent, determines what profitability we're going to see. So what are we saying here? Um, we're saying that let's see what the overheads actually are. So we can see we see some very careful. We're very clear about these overheads. These are kind of allocated specific overheads to M and to D and to C and to. There's nowhere we can go. You can almost call this maybe some sort of individual supervisor salary. So maybe there's a supervisor who only lives in M and who only lives in D, and the same thing. And this is unique to that product. There's nothing we can do about this. But then we have these general. Well, when I say we have general factory costs and we have machine setup costs, we need to find some kind of formula of distributing them. Um, so let's look at that. So we're told that with machine setups, well, I suppose whoever's doing more setups should take more of the cost. So let's see the situation. So the first question says here is that the setups are driven by batches. And what do we have? So you have your machine setup per batch. So for every batch, you have 4 machine setups. Um, just because it's a bit more complicated, and this is even more complicated. 6 machine setups per batch. So let's look at that. So the first question they want us to do is how many batches do we have? So like we said, it's 50 units in every batch, and you're selling. This is what you're selling, isn't it? So based on what you're selling, you will be able to find what this is. So let's do that. So 50,000. Yeah, number of batches here would be 50,000 divided by 50, and here it would be 75,000 divided by 50 because it's 50 in every batch. So right, and then here would be 100,000 divided by 50, and here it would be 25,000 divided by 50. Okay, great. So let's just divide that, right? I just wrote it so I could actually get my answer. So 50,000 divided by 50 is 1,000. I can easily do that. 1,000. 5,000 divided by, is that's what the case is? Sorry, not 5,000. Number of batches here. 75,000, sorry. 75,000 divided by 50 is 1,500. For C, I have 100,000. 100,000 divided by 50 is 2,000. And finally, you have 25,000 divided by 50 is 500. Right. So in effect, you have these are the number of batches, and in effect, you have what that's 1,000, 3,000, 3,000 plus 2,000. That's 5,000 batches. 5,000 batches, and it says here that you have 4 setups for every batch. So the number of setups, therefore, must here be 4 times 1,000, which is 4,000. You have 1 setup for every batch. You have 1,500 batches, or 1 times 1,500 is 1,500. 1 times 2,000 is 2,000. You have 6 setups for every batch, so 6 times 500 is 3,000. So I'll just add these together. So 4,000 plus 3,000 is 7,000. 7,000, 9,000. So let's just add those together. 4,000 plus 1,500 plus 2,000 plus 3,000 is equal to 10,500. Right, and that's your, and so we fill that in, right? So what are we saying here? So the cost, your total machine setup costs here is you have a total cost of machine setups of 598,500, and you have a total of 10,500 setups. So we can find, if you like, the cost per setup, right? Because we can just do that. So we have 598,500 divided by 10,500, which is equal to 57. And that's how we find the cost driver rate per setup. And now, now that I know, I mean, I know you had 4,000 here, 1,005. So I can basically better allocate this cost of 598. I can split that based on MDCL more efficiently. So let's do that first. Let's put in what we know. So we have these product specific costs here. 200,000 here, right? Yes. 20,000 here. Sorry, I've lost my page. Product specific cost. Where was I going here? Yes, here we are. 10,000 here. And finally, 421,500. Yes, and I can add that up. I'll do that in a second. My machine setups, well, my general factory cost, you can see here, because the argument here is that all of them must share that. So in terms of making decisions, you can't really allocate that because there's no real rational way of allocating that if you want to make a decision. So just kind of put that all the way to the side over here. We're not excluding it when calculating our profits. We're just saying you can't use that to really talk about. If you're asking who should we get rid of, we want anyone who's making a positive contribution is welcome. Anyone who's not is who we're looking to exclude, and we want to be as fair as possible. And factory overheads will not help us make that decision efficiently. So what do I have here? 57 is what you have per setup. You have 4,000 setups per M. So I'm going to be doing for M, I'm going to be doing 57 times 4,000. For D, I'm going to be doing 57 times 1,500. For C, I'm going to be doing 57 times 2,000. And for L, I'm going to be doing 57 times 3,000. Right. So let's just put those figures in. 57 times 4,000 is 228,000. And then the same thing here, 57 times 1,500 is 57 times 1,500 is 85,500. Then I have 57 times 2,000 is 114,000. And finally, 57 times 3,000 is 171,000. Right. So what do I have? I have my revenue and I have all my costs. So what I'm going to do, I mean, you can see this here. I mean, there's no point. Time is the issue here, and I've already done 12 minutes. So I'm just going to flick over to the answers and show you. I mean, we're literally doing the same thing, aren't we? You can see that there. Oh, sorry. Yes, that's 228, by the way. And you can see the 85.5. You can literally see I've literally done the same thing. And look at the profit here. The key point here is that L is now making a lot, is now making technically, I prefer calling it a contribution, a net loss, because we haven't quite put all the costs through it. But let's just say it's making a loss. So the key point here is now we think differently about this. Now the argument then becomes, oh, actually, L is the one who's at risk. And so that's sort of the point here. L is the actual product at risk. So the key point here is that technically we should discontinue L, technically. This is in contrast to when we initially prepared this and we had the idea that the problem children were D and C. On the contrary, actually, C is actually doing very well. And so that would have been a disaster. So continue M, D, and C because they're all contributing towards profit is the language I think you want to use. And definitely, if you discontinue this, you're having a saving, if you like, it's coming through, and you may be able to increase profits by even more than 12,000. But at least you're having a saving of 12,500 if you discontinue this. Now, the whole idea of the question does say, and the only reason the reason I did this again was because theoretically they want you to discuss a little bit about value analysis, just the theory, um, and the whole idea about value analysis is that give the customer, find out what exactly the customer wants and give them what they want. So if there is no need to put in any additional features that do not benefit the client, don't. If you're going to be putting in additional features, then you better be putting that into your pricing, is what the argument is, right? If they don't need any extra packaging, if it doesn't need to be there one day early, just give. If you're going to deliver a good literally the next day, then you have to charge the customer. It is literally, if you're if you don't need 10 kilograms of plastic and you can use 3 kilograms of plastic and the other kilograms just putting things on the side, just for fancy. No, 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 don't do that. The customer knows exactly what they need the product for. And that's really the whole idea of value analysis. To a certain extent, you need to carry out some market research to know what the customer really wants, because you see, you're trying to minimize. Remember, you can't do anything about your pricing. So what we're really trying to do here is to improve the process of production without compromising the quality of usefulness. This is the point here, usefulness. And I suppose bringing in some of your competitors and seeing what they're doing with their products, and how can you remove those things that are not needed without affecting the value of the product is really the moral of the story. Or it might be to do with design. How can we ensure that we retain the customer's perception of the product, and how this enables us to reduce our costs without, and yet increasing our profits. And that's how we deal with this question, CCV. Okay.